Welcome! This is a basic tutorial on options intrinsic and extrinsic value. This guide will cover what intrinsic value is, what the Black-Scholes model is along with its function, and extrinsic value. An option price can be split into two parts, its intrinsic value and its extrinsic value. The intrinsic value is simply how far in the money the option is, or put another way, how much the option would settle for if it expired immediately. For example, if you own a Bitcoin call option with a strike price of $3,500 and the current price of BTC is $4,050, then the intrinsic value of that option is $4,050 minus $3,500 or $550. This would be paid in Bitcoin at that moment, or 0.13584 BTC minus fees. Options only have an intrinsic value when they are in the money, so if an option is out of the money, then its intrinsic value is 0. If a call option is in the money, its intrinsic value is calculated as the underlying price minus the strike price. If it is a put option that is in the money, its intrinsic value is calculated as the strike price minus the underlying price. Here are some examples of the intrinsic value of options with various strike prices, given a Bitcoin price of $4,050. As we can see on the table, calls have intrinsic value when the strike price is lower than the current price. For put options, which profit when the strike price is higher than the current price, the opposite is true. We've discussed an option's intrinsic value, but there's also other factors which should be taken into account when an option contract is being quoted, the extrinsic value. You see, an option's extrinsic value is any extra value it has when intrinsic value is taken out of the option price. As a function, extrinsic value is the option price minus the intrinsic value. For example, where the underlying Bitcoin price is $4,050, if the call option with the strike price of $3,750 is currently priced at $500 premium, then its extrinsic value is $200. This is found by the option price, or current premium, minus the intrinsic value, or $300, leaving $200 remaining of extrinsic value. There are several factors that determine how large this portion of an option price is. The time left to expiry, the implied volatility, the interest-free rate and dividend rate, and finally distance between the strike price and underlying price. These parameters are entered into an options pricing model, and that will then give the options price. The most common option pricing model is the Black-Scholes model, and this is what is used on Deribit. On Deribit, both the interest-free rate and dividend parameters are left at 0, but let's look at an example of how the rest of these parameters affect the extrinsic value of an option, such as the time to expiry and implied volatility. First, we have a chart displaying how different times to expiry will affect the extrinsic value of options at each strike price. This is a fictional asset with a current price of $100 and a fixed implied volatility of 50%. The chart here displays the extrinsic values of call options in dollars for each strike price, and for various days to expiry shown in different colors. As you can see, all other things being equal, there is a clear correlation between how much time an option has until expiry and the higher the extrinsic value will be for all strike prices of this call option. The more eagle-eyed among you may also have noticed that the progression is not linear. With 240 days to expiry, the extrinsic value of the at-the-money call, this $100 strike, is $16. However, it's not until we get down to 60 days to expiry that the extrinsic value is halved to only $8. More on why this price premium on higher time frames occurs in a future lesson. Now, onto how implied volatility affects the extrinsic value of an option. Again, like our previous chart, an asset with a current price of $100 and this time with a fixed 200 days to expiry. The chart displays the extrinsic values of call options in dollars for each implied volatility percentage point, and for various strike prices shown in different colors. As you can see, all other things being equal, the higher the IV, the higher the extrinsic value of the option. So, we can summarize that the more time an option has left and the more volatile the underlying asset is, the higher the option premium is going to be. This is due to higher volatility assets having a higher chance of expiring in the money and so having intrinsic value. Notice also in each chart how the highest extrinsic value is always with at-the-money options, $100 in this case, and this decreases the further away from the current price you move in either direction. Note, however, that these charts only show the extrinsic value. The intrinsic component of the in-the-money options has been removed for the example. In summary, option value has both intrinsic and extrinsic value, as there are many factors which go into the pricing of an option. By understanding the fractions of each type that make up the option's price or premium, the trader has a greater understanding of this option premium. Deribit uses Black-Scholes with an interest and dividend rate of 0% to calculate the implied volatility and assist in the mark pricing of options. Usually this mark pricing is the average between bid and ask prices on the market, but for risk management purposes there are hard limits to this price, and it uses Black-Scholes calculated IV to set boundaries. There is more to cover with options, like the aforementioned time premium, but you should now have an understanding of some of the factors that go into pricing an option in Deribit. This was a brief video guide to Deribit options' intrinsic and extrinsic value. Thank you for watching.